Okay, right now what we're going to do is we're going to go through some example problems from the textbook that we are going to be using next year. So I've printed out a lesson for you. There are several in-class practices with lots of examples, and these examples and things that you're about to see are the things that you're also going to see in your independent practice here in just a little bit. If there's a page before this one, just ignore that page. We aren't going to do it. It may say 7.8 writing and graphing inequalities, but we're going to skip over that very first page and we're going to start on this one. So be sure that you're looking at the correct page in your packet. At the very top, it defines what an inequality is. It says it's a mathematical sentence that compares expressions. It contains the symbols less than, greater than, less than or equal to, or greater than or equal to. It gives you a chart, which is similar to what we did in our notes just a little bit ago. And it gives you some key phrases again so that you can see even some more phrases that you might see whenever you are working with inequalities. So we're going to go down and we're going to look at example 1. And it says that we need to write each word sentence as an inequality. So a number C is less than -4. So we're pulling back in those negatives and positives that we worked with a while back. And we're practicing also writing an expression in a way using an inequality symbol. So we've already practiced writing expressions. We've practiced writing equations from word form into algebraic form. So what we're looking for is a number C. Notice how they highlighted that. That is going to give us that C variable. And then is less than. And up here in our table, it lets us know that is less than is a key phrase for the less than symbol. So a number C is less than -4 is what our number sentence, mathematical sentence would look like. Number B, or letter B, says a number K. My variable is K plus 5. So K plus 5 goes together. Is greater than or equal to, so we need to use this symbol, and then we write the number 8. So it ends up looking like this. K plus 5 is greater than or equal to 8. Letter C says 16 is no more than. No more than means that we have a maximum. So 16 is my first number. Is no more than means less than or equal to. So it has to be less than, but it can also be equal to the maximum number, 4 times a number Q. And we represent 4 times a number Q by just writing it simply like this, 4Q. Again, you can use the dot for the multiplication symbol, but really you're going to start seeing algebraic expressions, equations, and inequalities. They're all going to be looking like this moving forward. Okay, so my inequality is going to be 16 is less than or equal to 4Q. All right, we're going to write the word sentence as an inequality. We have example practices here. If you want to pause this video and you want to try these 3 on your own and then check to see if you did it right, you can go ahead and pause now. Okay, if you want to keep going, here we go. Number 1 is a number N is greater than 1. So I'm going to have N as my variable, greater than 1. Number 2 says twice a number P. Twice a number P means that I am doing 2 times P. Is fewer than 7. Fewer than means less than 7. And then number 3, -6 is at least. -6 is at least. At least is a keyword for greater than or equal to a number Z divided by 2. So -6 is at least a number Z divided by 2. So hopefully yours looks something like this if you paused and then played and you were checking over your answers. If not, go ahead and make those corrections as you were listening to it, or go back and rewind if you need to so that you can hear it again. Okay, moving on to the next page of notes. At the top, it says that a solution of an inequality is a value that makes the inequality true. We talked about solutions just the other day when we were working with equations. Same thing. It is a value that makes the inequality today, since we're working with inequalities, true. An inequality can have more than one solution. That's what's different about an inequality than an equation. The set of all solutions of an inequality is called a solution set. So let's look at this table and kind of figure out what it's showing us. Over here, I have my value of x, just like a normal table would. And in here, instead of an equation, I have an inequality showing me x plus 3 is less than or equal to 7. So I'm going to replace my x with my 3, solve this part, which is 6. 6 is less than or equal to 7. If that is true, then yes, it is true. If I plug in 4, 4 plus 3 is 7. Is 7 less than or equal to 7? Yes, it is. But when you plug in 5, it becomes 8, which is not less than or equal to 7. So no, it is not true. Okay, so let's go down and look at a couple more examples. We have 7y less than 27. It wants us to use y equals 4. So I would plug in 4 for y. Notice how they put 4 inside the parentheses to show that it is 7 times 4, not 74. Okay, it is less than 27. I'm going to solve this side of the inequality sign. 7 times 4 is 28, which is not less than 27. So I'm going to draw a slash through that to show it is not less than, and it is not a solution. Letter B says 5 is greater than or equal to z divided by 3. And if z is 15, then I'm going to go ahead and solve what 15 divided by 3 is, which is 5. Is 5 greater than or equal to 5? Yes, it is. So 15 is a possible solution of the inequality. Now remember, inequalities can have multiple solutions, so there could be more. Okay, let's look at these examples. If you want to try these on your own, again, you can pause and then you can play whenever you're done and check over your answers. Okay, number 4 says p plus 5 is less than or equal to 12. I want to replace p with the number 6. So I am going to write my problem, 6 plus 5 less than equal to 12. What is 6 plus 5? It's 11. Is 11 less than or equal to 12? Yes, it is. So number 4 would be yes to answer my question, whether or not the given value is a solution. Number 5, w minus 12 is less than 4. If I replace w with 16, like it tells me to in my problem here, then I'm going to go ahead and do 16 minus 12, which is 4. And then 4 is less than 4. If that is not true, I'm going to draw a little slash through it and answer no, because that is not true. Now, if it had a line underneath the less than symbol, it would be true because it would mean less than or equal to. Okay, number 6 says a park ranger divides 90 visitors into n equal groups for guided tours. The inequality 90 divided by n is less than or equal to 25 represents this situation. Can there be 3 groups or 5 groups? And it wants us to explain. So what I want to do first is I want to plug in 3 for n because n means equal groups. Right here it tells me equal groups. So I'm going to work this off over here on the side. I have 90 divided by 3 less than or equal to 25. So 90 divided by 3 is going to be 30, which is not less than or equal to 25. So I know that 3 cannot work. We cannot have 3 groups. Well, let's try 5. So if I did 90 divided by 5, less than or equal to 25, 90 divided by 5 equals 18, which is less than or equal to 25. So this one would be yes. So can there be 3 groups? No, not 3 groups, but there can be 5. And my proof is right here in my work that we just did together. You can write it out in words, you can explain it in words if you'd like, but showing me all of this is also perfectly fine. Okay, because this is proving how you know that there can't be 3, but there can be 5. Okay, moving on to the next page. It says the graph of an inequality shows all of the solutions of the inequality on a number line. So kind of like how we did just a little bit ago in our page of notes in our journal, that's what we're going to be working on right now. We're going to be practicing more of that. So don't forget, an open circle is used when a number is not a solution. Whenever you don't want to include that number, you'll use an open circle. When you use a closed or a colored in circle, that's when the number is part of your solution set. An arrow to the left or right shows that the graph continues on in that direction. All right, so let's look at example 3. There's a lot of breakdown here, so we're going to talk a little bit about it. My problem says G is greater than 2. So I want to show G being greater than 2. Okay, here it's showing you an open circle because 2 is not part of the solution. It is not greater than or equal to 2. It's just greater than 2. So this is my starting place with the open circle. And then it says right here, test a number to the right of 2 and see if it would be a solution. If you plug in 3 for G, would that be greater than 2? Yes. So we know that's a solution. If I do the same with 4, 4 is greater than 2, 5 is greater than 2. So basically, I know that any number to the right of this open circle should be greater than 2. But if I tested one to the left and I plugged in a 1 or a 0, these are not solutions. So I don't want to draw my arrow that direction. Here is what it would look like. Open circle, arrow drawn to the right, with my little arrow at the end. That represents every single number in a number line, which is infinity really, goes on forever. Every number is represented that is greater than 2, okay? All right, moving on. Let's look at these examples, and if, again, you want to pause and try them on your own and then check, you're welcome to hit pause now. All right. Number 7 says A is less than 4. And guys, I can't remember. I think I might have added in some number lines for you to do this on at the back of your packet. If I didn't, then you can just draw a number line with me right now. It's not a big deal. But if I do have number lines at the back of your packet, you can go ahead and graph the inequality on there. Okay, so looking at number 7, A is less than 4. That is going to look something like this. So I'm going to start 4 here, and then 3, 2, 1, 0. Because it's less than 4, I don't want to include 4, and I'm going to use a different color. I don't want to include the number 4. I'm going to use an open circle to show that it's anything less than 4. So this is the answer for your first one. All right, number 8, n is greater than 0. If I draw myself another number line and I have 0, this would be like -1, 1, 2, 3. Okay, and again, it's not greater than or equal to, it's just greater than. So 0 is only my starting place, and it's every number to the right, showing that it is greater. And then the last one, -3 is less than or equal to p. So I'm going to draw my number line. I'm going to show -3 here in the middle, -4, -5, -2 on this side, and -1. Okay, so -3, I'm going to have my circle here. I need to notice that this time it's less than or equal to. So that means I'm going to color in my circle at -3. And because it's p that I'm representing, -3 is less than or equal to p, so be very careful when you're working with negatives because we want to show that it is the smallest number. So I'm going to show that p could be anything to the right, which means anything greater than -3. Okay, number 10 says identify an inequality that is represented by the graph. Find a number that is a solution and a number that is not a solution of the inequality. Okay, well, there's going to be a few different examples and solutions that you could do. So I'm just going to do one with you. Right now, let's explain what is happening here. I have a closed circle at 8. So that means that my solution could be 8, but it can also be anything less than 8. So n could be less than or equal to 8. So any number that is 8 or less than 8 is a possible solution. So 8, 7, 6, 5, 4, 3, 2, 1, negatives, 0, any of those would be possible solutions for this one. Okay, moving right along. Example 4 is connecting what we're doing right now to real life. So it says a firefighter's gear can withstand temperatures up to and including 700 degrees. So that's the maximum. It can obviously withstand anything less than that, but it can include 700 degrees. So we're going to write and graph an inequality that represents the temperatures that the gear can withstand. So it tells us here T is going to be temperature. Up to and including means that it can be anything less than, but it can also be equal to 700. So my inequality is T is less than or equal to 700. Because of this symbol here, it is a closed circle at 700. And I would draw my line to the left to show that it's any value less than 700. So then down here, it says the graph shows that 400 Fahrenheit is a solution. Check this in the inequality. So all they did is they took 400 and they plugged it in for T. Would that be true? Is it less than or equal to 700? Yes, it is. So now let's look and do a couple examples on our own. Again, you can pause and try it on your own and then check it, or you can keep playing and just listen as I explain. All right, you need to train for at least 6 7/75 hours to obtain a babysitting license. Describe the amounts of time that you can train and still not obtain a license. Use a graph to justify your answer. So again, I'm pretty sure I had graphs, but if I forgot, we'll just draw our own. It's not a big deal. Okay, so T is going to be representing, my time that I need to be training for, okay? So I'm gonna use T, and I need to train for at least 6.75 hours. So that means that I can train more than that, but I need to train at least that. However, if you keep reading, there's something very tricky and specific in here, and it says, describe the amounts of time that you can train and still not obtain a license, which means I am not going to include 6.75 is a part of my hours. So that is my key word there, not obtaining it. I don't want to include it. So it's going to be T can be anything less than 6.75. Now, if I did want to include the number of hours to obtain a babysitting license, then I would put that line underneath the less than symbol. But because I have this keyword here, not, it's telling me that I don't want to include it. Okay, you can also write this as a fraction, so you can do it just like this as well, 6 3/4. It's going to be the same thing. Okay, so let's show this on a number line. If I have my number line, and again, if you have a copy of a number line, you can do this on that. Okay, I'm gonna have a 6 maybe up here, and then 7, 8, and then I'm gonna count down 5, 4, 3, and 2. So it's 6 3/4 or 6.75. That's gonna be about right here. So I'm gonna do an open circle, and let me actually switch colors so that you can see it better. And then I'm going to extend it all the way to the left, showing that my hours need to be less than that 6.75 mark. Okay, number 12. Each visit to a water park costs $19. An annual pass to the park costs $90. Write an inequality that represents the numbers of times that you need to visit the park for the pass to be a better deal. So we want to know how many times I can go to the park where the pass ends up being a better deal. Now, your parents probably have talked about this before. Maybe some of you have like Frontier City passes. I do this every year when I renew it. I'm like, it makes so much sense because after X amount of visits, I pretty much pay off the amount of the pass. So it makes sense to buy a park pass if we're going to go more than 2 or 3 times. Okay, so this is kind of similar. If each visit to a water park is $19, but you buy a year pass to the park for $90, then we want to write the inequality to show how many times we need to visit the park. Okay, so basically that's going to look like this. 19 times X. We don't know how many times yet. So 19X has to be greater than the $90 that I paid for the annual park pass. Okay, when does it become more than the $90? So we got to go to the park at least how many times? How could we solve this if I want to know the answer? Okay, I'm going to divide 19 by both sides. You can actually solve this just like an equation, even though you have an inequality symbol. Okay, so here what I'm going to do is I'm going to divide, since I'm multiplying right now, I'm going to divide this. I'm going to divide both sides by 19 to figure out what X would be. This is if I was extending it and asking you to tell me how many times do I need to go to the park in order to have a better deal by buying the season pass. So if I did this, then I'm going to set up my problem just like this. 19 goes into 90 4 times, which is 76. Then you subtract, and this is 14. And I know that it's going to be a decimal number here, which I can't go to a park 4 and like part of a time. It's like I either go 4 or 5 times, so I would need to automatically round up. So if I were extending this and having you tell me how many times I could actually go, it would have to be 5 times before that season pass pays for itself, okay, with all of the number of visits. Okay, that's all of our practice that we are doing today. So now what you're going to do, there is a, I think it's maybe 3 pages of 7.8 practice. You're going to start working on this today. You're going to finish working on this tomorrow, and we will check it when I get back on Monday.